Hi there. My name is Johnson once again, and I'm going to be taking us through AI from origins to future. These are the slides, and I'm going to get started. We very well know the journey of AI's revolution from symbolic beginnings to today's statistical breakthroughs, exploring the philosophical questions that determine the machine intelligence. Yeah. So, what's AI's origin about? Simply, it simply has these milestones, and we have the symbolic AI of 1950 and 1980s, where early AI was focused on symbolic manipulation and logic using if then statements, whereby Alan Turing proposed the famous Turing test to determine the machine intelligence. Then we have fast AI, which was now closer in 1974. Here now AI was trying to revolutionize and period of reduced funding and AI's limitations in solving real-world problems. Then we also have expert systems, which are the ones which was the revival, with systems mimicking human expert decision making using vast collections of domain specific rules. Yeah. So the current trends and future predictions here, we have statistical and connectionist AI, whereby shift from explicit rules to pattern recognition from data using neural networks and deep learning. Then we have the second AI winter. This one involves skepticism and reduced funding due to limitations of rule-based systems. We have also super intelligence. This one was simply AI achieving super performance, specific narrow tasks like image classification and health diagnostics based on our what? On our project Retina AI. And our project Retina AI is simply based on detecting eye disease using retinal images. Yeah, so based on the weak versus strong AI perspective, well, weak AI computers as advanced tools that simulate thinking, whereby John Searle argued they just help for studying the mind, while in strong AI, computers can genuinely think and possess consciousness, not just imitate intelligent behavior. They possess that consciousness in them. That is the strong AI that has the beauty in it. So, our project was based on weak AI, but the debate centers whether computers can genuinely think or if they are not, if they are just advanced tools that simulate thinking. So, multiple intelligence in AI. Here, where we have the logical, visual spatial, we have the interpersonal and the linguistic. Logical, here the AI excels at processing patterns and applying algorithms. The visual spatial just have a narrow slice of recognizing shapes and features in the images, because our project is based on retinal image detection. So that means we look into recognizing the shapes, the sizes of the images with visual spatial. Linguistic does not really apply because it's language related, and here we are doing with pictures. Interpersonal also is not related because it currently lacks the ability to understand human emotions, which we are not applying in our project. So Retinal AI project, from theory that practice, which is our project, involves data mining evolution, whereby early eye disease detection used explicit rules. If the red dot, then it means there is hemorrhage. So the Retina AI uses connectionist models, which are deep learning, to recognize intricate patterns in retinal images. Then its intelligent types are: there is a logical mathematical, whereby processing pixel values; visual spatial, recognizing retinal features and the images. Then missing, that one it is missing, so we don't have it. It's the linguistic communication, since we are dealing with images. So the problem solving in AI, which is the core concepts, we have the state, which is a snapshot of world at a given time. So here the initial state is where you start, and the goal state is where we achieve. Then we have the operators. These operators provide actions or functions that transition from one state to another in the problem space. The third one is goal. So the goal is the desired end state of the problem that the AI systems aims to reach. That's like the goal state, because we have the initial, then the goal state, just in the searching algorithms. So then we have the state space. This one will collect all possible states of transitions. Finding solution equals finding a path from initial to the goal state. Yeah. So then we have the missionaries and cannibals puzzle. Here it just shows us the movement from the initial to the goal state, where I have three. Where I have the initial state, we have the bot moves, um, then we have the safety rule and also the goal state. Yeah, so initial state is where we like start from and where the start bank is. Then the boat moves carry 1 to 2 people per trip. Then of course the safety rule is missionaries never outnumbers to allow safety. Then the goal state, all the three M's and 3 C's on the destination. So classical AI problem demonstrating state space navigation constraints. This so the AI must find a sequence of boat crossing while ensuring missionaries are never outnumbered by cannibals on their side. Yeah, so the retinal AI problem definition framework. So in our AI, we have the initial state whereby raw and processed retinal image requiring analysis and classification. Then we also have the operators where we intricate mechanist calculations on pixel values performed by AI model. Then of course the goal state, here we classify label, identifying the eye disease, whether by its glaucoma or diabetic retinopathy, depending on what it is. So here our classification problem is framed as state space search, where AI searches through data features to search correct classification models. So we feed it those models and it searches so that it finds the right classification models. Okay, yeah. So we have problem solving by search, whereby AI systems navigate problem spaces using 2 fundamental approaches to find optimal solutions. So these fundamental approaches are simply uniform and informed search. So we very well know in uniform we have BFS, which is breadth first search, and DFS, which is depth first search. And of course, the breadth first search, it guarantees the shortest path. And in depth first search, we explore as far down. That means we go up to the deepest node, and also before backtracking. So in the informed search, this is the ESTA. ESTA, this one combines both cost, uniform cost, which is estimated goal cost for optimal path finding. Then the heuristic, this one is called the rules of thumb that estimates the cost to goal. So it estimates the uniform cost to the goal from the current state, right? So our knowledge presentation. So in original AI, we have symbolic AI approaches whereby semantic networks with concept nodes, okay, then frames with structured attributes. Then we have also the first order logic with constraints and predicates. So for example, if you have predicate x for all x and it has a symptom x homage or him or haj, then it has a disease for, then it implies that there is a disease for x in retinopathy. Yeah, so that's how it is. So the limitations for formalization: can all human knowledge, intuition, common sense, subjective experience be captured symbolically in formal rules? The challenge is many aspects of the human understanding resist formal symbolic representation. But AI reality, systems like Retina AI, the one we have, are sophisticated pattern matchers, so they are not true understanders. They're just there to match patterns, right? That is the reality. So inference and reasoning. So here, when it comes to inference and reasoning, we have the deduction, whereby deriving valid conclusions from premises. If premises are true, then the conclusion must be true. Then in the soundness, the system generates only valid conclusions from given rules and facts. Then in completeness, the system can generate all possible valid conclusions from available knowledge. Yeah, from whatever we feed it, it generates the valid conclusions from it. So when it comes to the Turing test versus the Chinese room, so we know very well knows the Chinese room, the system can manipulate symbols correctly without true understanding, whereby it just follows. Then the Turing test, so here if the machine exhibits a behavior indistinguishable from human intelligence, it's considered thinking. Yeah. So the reasoning under uncertainty. Here we have the real world challenge. Data is incomplete, noisy, contradictory. Traditional logic assumes true or false. Then, of course, we have the Bayesian solution whereby we update probability of hypothesis as new evidence becomes available. So keep on updating the hypothesis probability. Then we have the probabilistic models whereby the Bayesian networks represent variable relationships and probabilities for informed decisions. Yeah, so the AI planning systems, we have the initial state whereby it's the beginning state where the current situation with available resources and constraints. Then we have the action state whereby the strips uses preconditions and effects to create these actions. Then, of course, after that action state, we achieve our goal whereby the desired end state reached through the optimal action sequence. So, what's the frame problem? The frame, how does AI know which information is relevant without being programmed for every scenario? You get, yeah. So that's the frame problem that we are looking at. So machine learning approaches, we have supervised and unsupervised, whereby in supervised learning, we train on labeled data sets. So we shall train on labeled data sets to learn output mappings for the classification and regression, of course, for the images. Then in the unsupervised learning, it will allow us to find patterns in unlabeled data through clustering and association rule mining. Yeah. So in simple terms, retinal AI, which is our intelligence or simulation. So we are trying to rate. So ours is accuracy rate. It's going to have a 95 accuracy rate, whereby it can detect these images, and it has a potential superhuman performance in narrow diagnostic tasks, whereby if the tasks are a bit narrow, can give it high performance, like for superhuman performance, where it can actually read like a good human being who has intelligence. Then 0%, that means true understanding is not there, and it also lacks contextual wisdom, so unconscious awareness. So, in conclusion, is AI's optimal classification genuine intelligence or just sophisticated simulation of rationality? The system excels as a mathematical mind, but cannot form hypotheses, feel compassion, or appreciate beauty. It's just a mathematical mind. Thank you very much for listening. Have a good day.